You guys see that? You have to adjust that.
All right, cool. Thanks. Hi, everyone. I'm Craig Kerstiens. I work at Heroku. I run product for Heroku Postgres. We run the largest fleet of Postgres in the world. We've said that publicly in front of people that would know better, and they haven't corrected us, so we're going to keep saying it for now. But I've been at Heroku for about 3.5 years, run product for a variety of groups. At one point did some engineering, but no one wants me doing that anymore. So really quickly, some shameless plugs. I run a weekly newsletter called Postgres Weekly. Subscribe if you're not already. It's really end-user facing content, so not targeted at DBAs, but app developers doing things. I blog a decent bit. Postgres.app, if you're on a Mac and have ever run into problems with Mac ports or Homebrew, just don't use them anymore. Postgres.app is a nice drag and drop. And then Heroku, we run quite a bit of Postgres. So I give a variety of Postgres talks at conferences, probably 10 to 12 a year. And at most conferences, I put up a slide that looks something like this at the end or the beginning. Basically, this is why Postgres is pretty great. If there's something on here that you don't recognize, there's a ton of data types, transactional DDL, listen notify, which is basically pub sub directly inside your database. If there's something that's new on here, give it a look, give it a read. Tons of useful, awesome things, and when you need them, they're incredibly handy. And a quote, which is great for Twitter. This is actually the first time I can say, this actually is a quote from Daniel Farina sitting right there. I actually don't use Emacs, but basically Postgres is a great platform, more than just a relational database. It's moving that way, so it's kind of where it's headed in the way you should think about it.
There's a typo, you spelled Ben
wrong. But this talk is really about Postgres performance, really as an application developer of like, how do you look at it? What do you need to care about? Where do you begin? So really quickly kind of breaking it up. There is OLTP, which is web applications, the most traditional type. A straightforward web application kind of groups into this if you're doing transactional load. The other is OLAP, where it's kind of BI and reporting, and you're reporting across a broad sweeping set of data. Postgres can play really well here. I'm not going to talk at all about this, so if you wanted to learn anything about this, sorry. But really, Postgres, you can do different things there. A lot of MPP solutions are built on Postgres, Astrodata, Netezza, various versions, Greenplum, that play well here. It's a great building block, but stock Postgres needs quite a bit of work. Quickly kind of getting this out of the way. And by the way, I'm going to go pretty rapid fire through all of this. There's going to be kind of a lot of various pieces. So if there's any parts that are interesting, we can definitely come back to them in the end, or if you want to interject, by all means. So on the setup and config, if you're on Amazon, either use Heroku or Google PostgreSQL when it's not your day job. Amazon is sort of like hardware. It's virtualization on top of virtualization on top of virtualization that you have to treat very differently. So you basically want to tune your Postgres like the disks are not real disks as much as possible. And there's some other things you want to do. His talk goes through about the 40 configs you want to set. And basically set them and you're pretty much set. You should have to do it just once. If you're on any other cloud provider, you get a little closer to sort of real hardware. Again, PostgreSQL, when it's not your day job, it basically tells you all the things you need to set at a Postgres config level. And if you're on real hardware, this book's a little old, but High Performance PostgreSQL. It's written by a former colleague, Greg Smith. It's based on PostgreSQL 9.0. I hear through the rumor mill he's updating it, but I've heard that for, I think, a year now, so I don't know if it's happening. But it's still pretty accurate overall. He gets a little bit into dealing with SSDs and other things, and he's done a lot of examining of like Fusion IO and how you can tune it, where you can get some really great performance. So onto it, like once you've got it set up and running, this is, I think, where most people start to, like, where do I begin as an application developer? Can it just be a black box? From the, really 30,000 foot view, Postgres is really, really efficient at managing cache data. It's going to be better at knowing the distribution of your data than you are. I promise. I know you think you know better. You don't. So Postgres, if you want to look at your cache hit, basically what it's going to do is keep frequently accessed data in memory. Unused data it's going to throw out to disk, not keep it in memory. Obviously, disk versus memory going to be a lot slower. Running this, which you can probably not see at all, super simple query, you can get the cache hit ratio. Don't worry, you shouldn't worry about memorizing any of this. Just Google for it. It's all in the slides and online. And this is going to give you back this nice verbose response that looks like that. And basically what you're looking for here is you want to see a cache hit ratio of 99% or higher. 99% of the time, you basically want Postgres to be hitting memory when it's serving data. And this is, again, specific to web apps and OLTP. If you're doing like BI reporting, this is very different. As soon as this drops from like 99% down to even 95, you're going to see response times, performance really start to tank. Another key area is index hit ratio. So a little bit simpler of a query. What this is going to do is give you a pretty straightforward breakdown of the rows in your table and the percentage of times an index is used on that table. So here you can see if you've got a table with a ton of data that you never use an index, it's probably a good idea to add one. I would say some rough rule of thumb, cache hit ratio, anytime I look at a new database, this is the first thing I'm going to look at and see how is it. And I'm basically looking for something around 99% or higher. Index, I'd say maybe 95% or higher. It really varies on the use case, right? If you're always querying users by email, you should have an index there. And I have it grayed out there where rows are greater than 10,000. If you've got a really small lookup table that's 100 rows, it doesn't matter too much. But as soon as you have a sizable data table, you want to see most of your hits be against the index there. So something that's really handy, how many people here have a vimRC? Most people. How many people have a pSQL RC? Okay, a few people. That's actually a really good percentage breakdown from when I usually ask that question. So pSQL RC, and I don't know if you can see that at all. Basically, you can do a variety of things. You can set specific commands. One thing that's really nice is you can name queries. So I have down here this set show slow queries, which will show, I'll get to the query in a minute, but you could also have like, what's my cache hit here? And you basically just run cache hit on any database you're connected to, and you see that data. So you don't have to remember these handy things. Just keep it locally on your client, and it's incredibly handy. So how do you understand specific query performance? Given something really basic like this, it's great. Postgres, for every query it executes, has what's a query plan underneath. Putting explain in front of it will show you what it's going to do and how Postgres thinks it's going to perform, how long it thinks it's going to take, rows it thinks it's going to come back with, how many it's going to discard, all this data. So you get something super clear like that that's nice and intuitive. It's not really. It's not too bad. Essentially, there's a startup time there. Don't worry about that. You don't need to know too much about it. The max time is the more important one, and the number of rows returned. If you just update that with explain analyze instead of just explain, it's not only going to show you what it thinks it's going to do, it's going to actually run the query and show you what it actually did. So in this case, you can see kind of in the grayed out what it thought it was going to do and then what it actually did. If you're knowledgeable on Postgres, you'll see that my stats are super off there because I bulk loaded a bunch of data. But in a production system, they're actually going to be pretty accurate. If there's dangerous things that may bring down production, don't run explain analyze because it does actually run the query. And if it's taking a long time, people may get angry. So that actual time is a big thing of what I'm going to look for in an explain analyze. Some rough guidelines around this, and this is really specific on, between applications. But I'd say, a reasonable page response time is less than 100 milliseconds. Common queries should be less than 10 milliseconds. More rare queries, less than 100 milliseconds. And generally, I say I can get down a query response time to about 1 millisecond, a common one. That's not 100% of the time, but that's where I know I can get it to. So coming back here, in this example, we've got a query that returned in 295 milliseconds. So obviously, I can refine and tune that. Looking at the filter condition there, which is salary, I can just add an index on salary and then bring it down to 1.7 milliseconds, which is where I'd expect it to be. Another kind of small tip is if you've run this twice, you're going to get a very different result because it's in the cache. If Postgres just returned it and it's still fresh in cache, you're going to get something that looks very different. So changing kind of the parameter on the query is an important thing to do when testing this out. So that's great if you've got like a problematic page, but coming back, if you want to look at an aggregate view of how do I know how performance is doing, the best thing in Postgres is pgstat statements. It's existed for a little while. It actually became useful in Postgres 9.2. So if you're on an older version, upgrade just for this alone. This gives you a ton of visibility at a macro level. So what it does is, again, I don't know if you can see that at all, record every query that's run against your database and normalize it. So in this case where I've got select star from users where email equals question mark, if I was actually querying where email equals Craig at Heroku, it's going to swap that constant out and parameterize it for me. And it's going to record how many times it's run, how long an aggregate it takes, all these things of like how many blocks were dirty during writing, how many blocks were read, all of these different things which you can dig into. The most basic example, and I think single most helpful query in diagnosing at an aggregate level, it's going to look something like this. What this is going to do is run the total number of time a query is taken against my database, how long it takes on average, and what the query is. So I can see the most expensive queries in aggregate against my database. It looks something like this coming out. So I've got a couple of queries here. One that's taken 295 seconds in total. On average, it takes 10 milliseconds. Another that's 200 minutes in total, and on average takes 80 milliseconds. Knowing I can get either of these down to about 1 millisecond, I could give a lot of time back to my system by working on the second. So I could save kind of 2 orders of magnitude and give quite a bit of time back to my system there. The total is since the stats have been reset. So it's a good thing to do every so often. I wouldn't encourage doing it super regularly. I do believe it also will phase it out some over time. But it's since the stats have been capturing initially. So there's a command to reset your stats. I wouldn't encourage frequently running it, but if you've done a ton of maintenance, it could be a good time to reset it. So indexes, Postgres has quite a few. If you're anything like me and you look at all these and even read the Postgres docs, it looks something like this. The docs aren't super helpful. They tell you the algorithm it is, but that's about it. So some rough rule of thumbs. If you talk to like a Postgres core person, you'll hear, no, this one is more finely tuned for this very narrow case and this one for that one. If you aren't using anything advanced in Postgres, if you're not using any of the geospatial stuff, if you're not using full text search, if you're not using some of the more unique data types like arrays or HStore or JSON, you don't care. Just say create index, and it's what you want. It's a standard B-tree index. This is what most other databases have. A lot of other databases have only this type of index. Not to name any names, but most others. Gen index is generalized inverted index. rough rule of thumb, if you've got multiple values in a single column, so HStore, which is a key value store directly inside a column in Postgres, arrays are the kind of the two rough groupings here. Sometimes gist will be smaller on disk and just as efficient, but you can experiment with them if you want to fine tune it that much. Gen is great because what it'll do is index every key and value inside that column, so you don't have to worry about it. Basically, if you're filtering for something, it's just going to be fast. Gist indexes are rough rule of thumbs, full text search, shapes. If you're doing things with PostGIS, it's a great solution there. Again, sometimes Gen can be helpful, but generally Gist is the best one. For the others, k-nearest neighbor is great for similarity. How similar are things? Space partition Gist, I say this every time, and I still don't have a better line for it. I've had this explained to me 50 times. All I know is it's good for phone numbers. So if you have phone numbers in your database, use it. There was some explanation of pizza places and location and something, and sure. Vodka is one that's coming soon. I hope this is not the actual name. So almost all of these indexes were created by a group in the Postgres community known as the Russians. They're a bunch of crazy they're not even computer scientists. One's a professor of astrophysics who just hacks on Postgres for fun. They come up with crazy ideas, go into a cave and come out, and you ask why you use it, and they say, it is good, just use it. And mostly people do. So vodka is a space partition Gen index. Not sure when you would use it. The Russians think because we have Gen, we need vodka. I just hope that's the working name. So more indexes. So those are types that apply to various data types. There's also ones that I don't even know how to describe them. Just kind of a different type of index. So a couple of the main types, conditional and functional. Hopefully they're just pretty straightforward in what they do. Conditional one. So an example here I use is if you're building a phone book application, right? And you have everyone's previous address. You probably don't care where they lived 5 places ago, and you don't care if that's slow. So if you wanted to index where current address is true, right? So you're indexing only 1/10 of your data. It can be really nice. So if you want to index a subset of your data, this is really nice. Basically, you just say create index where this condition is true, and it just works. Another one is functional. So if you want to index on the result of some built-in function in Postgres or some custom function. So in this case, I've got some JSON in my database. If I wanted to index on, in this case, like the numeric value, and then the numeric value where it was greater than 10,000, I could do that. So Postgres just views this as JSON, but the index is going to maintain the result of this in the index. So whenever I query using this function, it's going to use that. An important part of functional indexes is if the same input to the function returns the same value, which in a database, I hope that sounds a little crazy, unless you're doing random data manipulation in a function with your data inside your data, reliable database. Using immutable is important because Postgres treats things very differently. So as long as the same input generates the same output, which I'm going to guess is 99% of the time, you want to use immutable when creating this. So there would look hopefully like what you'd expect. You're creating an index on the function right there. So another great thing, create index concurrently. If any of you have used other databases and added an index and it took a few minutes, a few days, a few hours, Postgres has the ability to add an index and not hold a lock while writing data, while writing the index out. And I say that it's not 100% true. It holds a lock for a few milliseconds. But basically, it's going to be a lot slower, and as soon as that index is done creating, it's going to swap over and start using it. For most applications running in production, this is probably the default of what you want. One caveat is it can't be run in a transaction, so you kind of need to do it outside of ban of like normal migrations. So if you're using like South with Django, you kind of have to break out of the transaction, which it runs in default. HStore and JSON is everyone here familiar with HStore or JSON? A few nods. So hopefully JSON makes sense. HStore is a key value directly inside your database. So there on data, the column name, I have an HStore, and I can just insert random things to it. It's really nice and efficient to mix relational data and non-relational. You can just add things really easily, really simply. We use it in production at one of our largest systems at Heroku that powers Heroku Postgres, and it performs great. I usually get the question of, how does it scale? How does it perform? And we run a pretty large system and don't see problems. It works something like this. So some of the limitations around it, it's a key value data store. You can filter on it, but it's only strings, basically. There are no types in it. So it's a little limiting there if you want to put in numbers and that kind of thing. And you can't nest things. That's the other thing. So it's not a full document store. In contrast, JSON came along in Postgres 9.2. It was basically validation that it was JSON, and then it shoved it into a text field. So it was of really, really limited use. With HStore, indexes work. So gen and gist indexes work, which makes everything really fast and performant. With JSON, you have to have functional indexes here. So anything you want to index and have be fast, unless you're grabbing the whole document, have a lot of fun creating all your indexes here. Postgres 9.4 is going to make this a lot better with binary JSON, which did get committed, and it'll have gen support. So if you're looking at using JSON, I'd probably wait till Postgres 9.4 where it's a whole lot better. But that all really depends on your use case. So like I said, JSON-B got committed. The world's a happy place. Postgres is now a document store. Forget about MongoDB and all that. Just use Postgres. So pooling is another common topic. If you're running a small, single process website, you really don't have to worry too much about this. There's a couple of options as soon as you get to any size, though. There's an application kind of framework layer, and then standalone daemons. On the application framework layer, Django has persistent connections in 1.6. Rails has had it for a little while. Basically, look at it and turn it on. It's a good thing. Here, basically, your framework's going to keep a pool or a connection open. Whereas if you don't have that, it's going to have to negotiate the connection each time. And you're looking at anywhere from 5 milliseconds to 50 milliseconds, depending on if you're doing SSL negotiation and other things. So a long time in the request where it's not actually doing anything of value. The other options I would say are, at a bigger scale. As soon as you have 100 connections open to Postgres, I'd say you want to start to look at one of the standalone daemons, just because they can get a lot more efficient. So Postgres has some overhead on every connection it has, of about 5 to 10 megabytes, I would say, overall. So at about 100 connections, there's other things that start to come into play that just create a problem. When it comes to what options do you have, there's PG Bouncer and PG Pool. PG Bouncer, basically use it. It takes the philosophy of doing one thing and only one thing really well, which I tend to like and align with. PG Pool does a lot of things kind of okay. If you need a lot of crazy use cases, poke at it. But PG Bouncer is kind of the de facto within the community. I'd say the one that's pretty much won out. So scaling. The easiest way to scale your database is throw more hardware at it. Really it is. It just kind of works. Give it more memory and it's going to work better. And at a certain point, if you need to scale otherwise, adding cache by scaling up is one way, but you can actually scale it out as well. So a nice thing about replication with Postgres is if you run a replica and send traffic there, it's going to keep a completely separate cache. So they're not going to try to keep the same things in cache. They're going to keep their cache based on their own query workload. So it's nice that you could send specific models to one read-only database and then all of your other traffic to another and kind of optimize it that way. And so it's kind of an easy, cheap way to shard without having to go down all the hard work. So when it comes to replication, there's quite a few options. Sloaney, Londiste, Bucardo, PG Pool. There's also a couple of more lightweight ones, so Wally and Barman. Postgres, as of 9, I'm going to get this wrong, 9.0 had streaming replication. It was okay. It's gotten a lot better. It's improved a good bit. It does have some rough edges. Wally's a really lightweight Python utility that just helps kind of with some of the archiving, the plumbing, and getting streaming replication set up, and then Postgres handles it from there. Barman's another tool. If you have no idea what you're doing around replication, I'd encourage you to look at one of those two. They're straightforward. They're easy to use. If you really want something more complicated, I'd actually say just hire a Postgres consultant. There's a few major shops that do this. Let them set it up, make sure it's set up right, and then it's pretty okay after that. Backups. So backups are another area of that actually can have performance implications. There's two types. The type that most people, I think about is what's known as a logical backup. When you do a PG dump, that's a backup. When you move that around and restore it somewhere, it can be human readable. It's portable. This is what most people think of. The other type is a physical backup, or also known as a base backup. So this is the physical bytes on disk. You need this to set up streaming replication on Postgres. Generally, it's so kind of side by side. Logical, it's great for moving across architectures. Great for portability if you're moving from production down to a local dev environment, that kind of thing. But it does have load on your database. And if you've got a pretty high transaction volume database, it can have pretty significant load. And I would say a rule of thumb is it works well under 50 gigabytes. Sure, it'll work on a terabyte if you have no load on your database, but I don't know people with terabyte databases that's the case. A physical backup, it's a little more initial setup. It's not as trivial as just running PG dump. It's less portability. I've heard rumors that it works across architectures and that kind of thing, but that's very much guaranteed to not always work. It's an accident that it works if it does. But it has limited load on the system, and it is pretty much what the community uses at a larger scale. If you're at 100 gigabytes or terabytes, this is what you want to be looking at. That said, I'd still say logical ones are good to run even if you have the physical ones, because they can detect corruption and other things. So it's not necessarily use one or the other, but kind of rely more heavily on physical for daily backups. And logical backups are great on a periodic basis. But I wouldn't use them at a certain point if I were, large and running a production site as my primary backup. So I flew through a lot of things there. Kind of a quick recap. OLAP, like I said, is a whole other talk. They're basically disk I/O is important. Order on disk is really helpful. PG reorg is a crazy thing that reorders bytes live on disk on a live database, and if you run it, it can work amazingly, and you can also randomly lose data. So you should know what you're doing. And then there's a ton of MPP solutions on top of Postgres. So look at them if you're really kind of digging hardcore into this space. Redshifts a really interesting one that was sort of Postgres 5, 6, 7 years ago, when it's pretty far from it now, but you still see a lot of the influence. And there's a ton of others that are really doing interesting things. For OLTP web apps, the number one thing is make sure the bulk of your data is in cache. If it's not, add more cache, so either scale up or scale out. Optimize overall query load with PG stat statements, unless you're really troubleshooting like one specific page where a query is a problem for you. But PG stat statements is going to be the easiest way to get a ton of headroom back on your system. Just use indexes efficiently, use the right types, check where you have a ton of data in a table where you're not using an index. And then again, when cache sucks, really just throw more at it. Kind of a mix of all of these things. And as an application developer, you're going to give a lot of headroom back in running a production site. Cool. Thanks, and happy to take any questions. Yeah.
So with analyze and vacuum, first can you kind of tell me like what sort of performance impact an out-of-date analysis can have, and also what can happen with that if vacuuming, auto-vacuuming doesn't really...
Yeah, so the question was, I guess, can I talk a little bit about if you don't have proper kind of, Postgres doesn't have up-to-date stats and you need to analyze your data, and then, what are the implications of vacuum and auto-vacuum and how does it all play in? So the short of it is Postgres is going to be really good at keeping the stats up to date. The time that it's not is when you do a bulk load of data. So if you've recently loaded a whole new table or really updated a ton of data, the stats are going to be out of date. They're going to catch back up when Postgres, the system is at a lull. So if you've got like a batch process that runs at night and loads a ton of data and then you immediately run reports on it, after that bulk load, I would schedule an analyze. But if you're not immediately running reports, I'd let Postgres kind of do that for you. It's going to do a pretty good job of that. It's just like immediately after you do a bulk load, it's not going to be up to date. Vacuum, auto vacuum has gotten better and better. It used to basically be useless. Auto vacuum works pretty well. But if it's not, there's a variety of parameters that you can tweak. And I'd say try random ones. It's a little bit of black magic right now. There's not a great guide. If you're at such a high transaction volume where you're updating things, deleting things, and auto vacuum just can't keep up, you're at a pretty high volume, and you may want to start looking at doing some more interesting creative things. For the most part, though, you've got to be at a really, really high volume of updates or deletes for that to happen. And I can probably point you at some resources for that. But it's definitely a little bit of black magic to tweak auto vacuum to be really efficient there. Okay, yeah, so what is vacuuming? So Postgres under the covers is one giant append-only log. So when you delete data, it actually writes new data, and then it goes in and cleans that up later. So Postgres monitors kind of when it's active and when it's at a lull, and it'll go in and clean up that data. So you can have a lot more data sitting on disk that Postgres just flags as dirty, like it's a logical delete, and it'll go in and clean up. So if you've got a really, really highly updated application or where you're deleting data, you can have a ton of bloat where you've got data sitting around that's not really there and wasteful, and Postgres has to search through it when it's querying data. So one tool, if you're on Heroku, we have a PG Extras plugin for the tool belt. If you're not on Heroku, go look at the queries in it. We have one for bloat that'll show you how bloated certain tables are. So what's the ratio of how much is just like dead data to actually live data? And I think we actually talk about some rules of thumb of like when do you need to go in and like clean up, when is it a problem? So running vacuum manually will go in and fix that. But Postgres is usually pretty good about doing it itself. Yeah, if you run it manually, there's some load, but it's not, it really depends case by case. Yeah.
So at one point you said one of your queries got down to about 1.7 milliseconds or something, which is where you expect it. How do you know what to expect? Is it just based on experience?
Yeah, it's generally based on experience. I know that I'm going to have to, hit something in memory It's going to have to go through certain parts of Postgres on the executor and figure out what to do. Also, a lot of times it will have to hit disk even if it's in memory anyways, if it's using an index. Postgres 9.2 came with index-only scans. So this comes back to kind of how indexes work. And when I delete data, Postgres doesn't know if it's actually deleted until it hits disk. So I know from a rough rule of thumb, basically from seeing a ton of systems that, yeah, you should be able to expect a query to be about 1 millisecond. And that all depends on, if I'm reading one record, if I'm reading hundreds or thousands and scanning those and doing aggregation, that's a little different. But for, grabbing a few records, which is most web applications, it's largely experience.
Can you speak to just like working with sharded databases, and what tools might be available to query across shards or anything like that?
The question is, can I speak a little bit to working with sharded databases? Any kind of recommendations or pieces? It's hard. It's painful. Postgres isn't perfect at it. Tools are still early and rough. It's kind of the really, really rough answer to it. Basically, I would start with a really, really large pool of actually, the first place I would start is Instagram has a great blog post about it. They've even got some better talks where they talk in more detail. So I would start there. What I would start with is a really, really high pool of logical shards and then having physical shards there. If you're spreading reads across different ones, today I'd probably seriously look at using foreign data wrappers in Postgres, probably. They're not amazing for performance, but they're getting better. Foreign data wrappers allow you to query from inside Postgres to some other data source. So you can easily do it to another Postgres database, but you can also query Redis, Twitter, LDAP, all sorts of other crazy things from inside Postgres, just using SQL. And the Postgres one's getting better and better. So it's kind of a nice tool to be able to, roll up across all of your Postgres instances. I'd set a really high logical set, gradually increase my physical shards. Django has some rough tooling at the routers to kind of deal with some of this. Discuss has talked a little bit about how they do it. I would basically look at something like Wally to maybe help, or start to look at some of the more complicated tools as well. Sloany is one tool that can help quite a bit there, but again, it's one of those tools that I wouldn't be excited to run. You do the wrong thing and data can just disappear. I think Bucardo helps a little bit with it, and it's a little more newer. I'd start to probably look at some of those tools if a basic kind of replica model that I could deal with a little bit of downtime and then promotion wouldn't work for me. DB-Link is basically a predecessor to foreign data wrappers. I'd use foreign data wrappers now. If you're on an old enough version where foreign data wrappers aren't that great, I'd try to get up to a newer version, really. Foreign data wrappers have been around since 9.1. There was a Postgres one in 9.3 that is really good. Does some predicate push down. It's not great for joins across. If you're joining across two data sets, it's going to pull back the full data set and then do the join, which can be pretty bad. But if you can do the right conditional pushdown, it can be reasonable. But I actually think the 9.3 one was also released open source as well. So if you wanted to build it for 9.2 as a extension, you could do that. Yeah.
Is there a reason you didn't include the hash index?
Don't use, the question is there a reason you didn't include the hash index? Sorry, don't use it. It's not good, it's not performant. It can create corruption. Like, it will corrupt your database. It'll corrupt the index. Yeah, so if your database crashes, you're losing data, and it's bad. Basically, it should not exist.
Does it still exist
it's still there, I think. Postgres, the community is really bad about killing old things. We have seen more cases, like a higher percentage hit rate of someone using that and corrupting data in their database than almost anything else. It's just not good. It's not that performant. Another index is going to be more performant, not corrupt your database. I just wouldn't use it. Yeah.
For connection pooling, if you have like read slaves, is there a reason why you would like pool connections to a read slave instead of like adding more read slaves if you're streaming your application, or how do read slaves plus connection pooling and all that go together?
If you've got anything that's connecting, so if it's the question was with connection pooling, how does it factor in with read slaves? Would you still add it on? How does it all play together? I would always have an application level, like at least persistent connections or some small pool at my framework layer, just because I don't want to have to grab and negotiate that connection. That takes time. Would I always do it to a replica? At about 50 to 100 connections, I would, just because it's consuming memory. Even on the replica, the connection pooler like PG Bouncer is going to be really efficient at that. It's not that hard to run. It works pretty well, and basically you're going to get more performance out of the replica too. So as soon as you're at a high amount of connections, 50 to 100, and especially over 100, it's just going to save you memory and money overall. Yeah.
Would you run multiple instances for PG Load Balancer or for the payment, or like would you pool multiple databases through a single pool instance? Or?
Yeah. So the question is, would I pool multiple databases through like a single pool instance? Generally not. PG Pool does crazy things there where it can route queries magically to certain ones and other things. I generally just put a PG Bouncer in front of each Postgres instance. Or on the application side, either or. Like, there's some crazy setups. Instagram runs it both on the database side and on the application server, and backs everything by SSDs. And if something fails, they run 2 other SSD instances and just fail over. Like, it's kind of crazy some of the things they do to really tweak that performance. I wouldn't worry too much about that early on. I just run it somewhere, in front of my database to basically offload that performance. Cool. Thanks.